You built an amazing AI agent that's smart, that's efficient, that's fast, and it works perfectly for simple tasks. But the moment you want to build something complex, like writing emails, analyzing data, writing code, and then reviewing your results, your single AI agent hits a wall. That's why the smartest teams, they're not building bigger agents, but what they're doing is they're creating agent orchestrations. In today's session, I want to cover exactly that. I want to cover the multi-agent orchestration patterns. And if you can see on the screen, these are the four different patterns that I've seen across multiple frameworks that we have in the market as of now. And in the last video, we used a agentic AI framework called Strands. So Strands was open sourced by AWS. Now it has these multiple orchestration patterns for multi-agent scenarios. However, this topic is not limited to that. So there are other frameworks as well, like Crew AI, LangGraph, and so many other closed source agentic AI workflows or frameworks are available, which you can leverage. The reason I want to cover this topic is irrespective of what framework you choose, these are patterns which you can implement on those frameworks as well. And today we are going to discuss these four key approaches. We'll start from the very basics, hierarchical in nature, and then we'll all go all the way up to the peer-to-peer complex scenarios. So let's start with the first pattern. So the first one is hierarchical in nature. So it starts with the main director, or you can say orchestrator, or you can also say manager agent that delegates the task from the top down. The tasks are delegated to multiple other agents. So these agents or these workers would perform those tasks based on the orchestration or the instructions that are provided by the main agent. And upon execution of specific tasks that each worker performs, the director will receive the results from these worker agents. Now, at the end, the final summarization or the final result would be published by the director after consulting these multiple worker agents. Now, in Strands, we have already discussed this. This is a concept called agents as tools. You spin up an agent, which is the main agent, and you have these multiple agents which acts as tools which are available to the director or the main agent. And there's no concept of sequential execution. Director decides when to call which worker based on the need of the request. The second framework that I've seen is called Swarm. Now in Swarm, we don't have a central authority or central agent that orchestrates the tasks across these multiple agents. What it does is that we call this as a swarm because there are multiple agents that are available and there's a shared memory that all of these agents are sharing. Now, think of this as a brainstorming session. So if you have joined a meeting room where you have these multiple people sitting together and they are brainstorming on a specific idea, every person comes up with their own idea and then they contribute to that shared memory in that meeting. So the same concept applies to the swarm agent pattern as well, where these are multiple agents are interacting in dynamic fashion and they have a shared context that they're working on. And in Strands, we have an agent type called Swarm, as the name suggests, which does exactly the same. Now, the third pattern is an important one, and I've seen a lot of people using this, and because of the graphical nature of this, what it's called is, as the name suggests, is graph-based. Now, in graph-based, you have the control to create that whole orchestration. So you're not leaving the decision-making to the agent or the orchestration agent. You are making the decision of when to choose which agent. So you can have, for example, a graph where you execute tasks from 1 to 10, and these different tasks you assign to multiple agents, and you can have that in sequential manner, or you can have a hierarchical manner based on some conditions that you add as part of the decision making when to transfer the context to another agent. Now, this is very important when you are building complex AI agentic workflows where you want to have these multiple agents and you're not leaving the agents to make the decision when to call a specific agent, like we were doing in the first type, and even in fact in the swarm as well, You are leaving the decision making of which agent provides what input at what time. Now, with graph based, you have more control. And that's where a lot of people are using that to be able to create these different complex orchestrations. And in that, you can create these quality gates based on some conditions and when to call the other agent. So it's very complex, and you can build these complex orchestration scenarios using the graph based approach. Now, the fourth one, peer to peer, is a complex orchestration pattern where apparently if you look at it, it seems similar to the swarm pattern. However, it's different in the sense that swarm pattern was implemented in the same application where you have assigned these multiple agents some tasks and they were doing brainstorming across each other. However, when it comes to peer to peer, we are moving outside of the boundaries of a single application. You can have in multiple agents in your organization. And going forward, we'll have these multiple agents that would be available on the internet. So you, you're creating an agent and you want to interact with another agent which is outside the boundary of your application or outside the boundary of even your organization. You want to communicate with the other agents. There's a protocol called A2A, agent to agent protocol. That protocol is going to enable these peer-to-peer agentic workflows where there will be multiple agents that would be communicating across these different agents, across the internet, across the organization. So this is something which a lot of people are already implementing, where they're integrating the agent-to-agent communication, where we are moving towards that agentic AI workflows. And this concept is a decentralized network of peers of agents, where the agents are actually communicating with other agents. So these are the four main types of multi-agent orchestration patterns. And if you're interested in implementing any of these and you need help, just write me in the comments below and I'll be able to create a new video on these specific topics. But I hope this helps. And if you are interested in any other topic, just leave the feedback. I really appreciate your feedback. Thank you so much for joining today's session. See you next time.